Hello and good evening, CSI257 students at Anne Arundel Community College for the fall 2014 semester. And this is the third of 4 Cisco Networking Academy courses, and this is the Scaling Networks course. This evening's packet tracer tutorial is going to be on packet tracer activity 5.1.2.12. where we're going to be looking at how to determine the DR and the BDR. And I have a number of additional resources that I'd like to make known to you this evening to further your understanding of the OSPF DR and BDR election. Okay, so let's go ahead and we're going to talk about those additional references here in a second, but right now we're going to jump into packet tracer activity 5.1.2.12. So let's go ahead and start here with step 1. It says wait until the amber light link lights turn green, and so they have. And the packet tracer's been open for a while. I actually opened this a couple days ago. As you can see here at the bottom, it's been on for, looks about 29 hours. So we don't need to click fast forward. So step 2, verify the current OSPF neighbor states. And so if we were to log on to router A, and you can see here that we've got the font is nice and large. So on router A, I'm going to go from user exec mode into privilege exec mode. And there's a number of commands that we can run. If I do show IP OSPF neighbor, sorry, show IP OSPF neighbor, I always get the typing so fast, get the S and the P backwards. All right, and so this allows us to see our OSPF neighbors, so I'll make that a little larger there. We can see the neighbor ID, and the key thing to remember here, and we'll look at a show run, the neighbor ID, if I do a show run on router A, we'll be able to see here that we've got a loopback address assigned. We've got a loopback address assigned further up. There's no router ID assigned, and there's no IP OSPF priority assigned, right? So you can see here under the OSPF 1 section, all we have is log adjacency changes, and then we have our network statement that simply activates the OSPF process on any interface that falls within this /24 subnet. So anything 192.168.1.1 all the way to 254, an interface with that IP is going to have the OSPF process started on it. And it's going to be listening for hellos. And so here is that interface. It's gig 00. So you'll notice the loopback address, and we're going to talk about this in a second as to how the loopback address plays into the DR and BDR election. So let's remember that our loopback address, loopback 0, is 192.168.31.11. Okay? So again, if I do a show IP OSPF neighbor, you can see that the state is full, and this is the OSPF state machine status right here, and it's full, and it sees this as .22 is the BDR, and it sees the router with the router ID of 31.33 as the designated router on this link. And so the key thing to remember here is that while this might be an IP address on an interface, including a loopback interface, this is actually the router ID. This is how it's being identified inside of OSPF. And so the actual IP address of that router is over here. And so .2 is for router 2, and .3 is for router 3. And if we look up here, you can see the loopback 0 address. And so right now, OSPF is using the loopback addresses to determine what the neighbor ID is going to be, or how the routers will be identified in OSPF. And so a key thing to remember in the DR-BDR election process is the 4 criteria that are used, or the 4 methods that are used to determine who will be the DR and who will be the BDR are, number 1, it's first going to look at the highest router OSPF priority. So you can set the OSPF priority on the router, and the router with the highest priority will become your DR. And the router values range from, and I'm just going to write here a little bit on the screen. I can find the mouse here. We got to get the Bamboo tablet plugged in real quick. All right, so we're going to connect that to the Mac. All right, so when we talk about the election criteria, the election process that takes place, and we'll come up here and we'll get the Bamboo paper, open that up, and close this down. Apologize, I thought this was already plugged in. So we'll come into the notebook here. So the criteria for the DR election. Whoops. Bring this guy back over. So the DR election. So the first criteria is highest OSPF priority. And that's the first one. All right, and the priority values range from 0 to 255. And the key thing is that 0, if you set your OSPF priority to 0, that means that you don't want that router to participate at all. By default, and I guess I'll put 2 slashes here, so the default is 1, right? And you can see down here where it has the priority listed. So we're going to take a look at those in a second. So the default is 1. 0 means do not participate. 255, if you set that as a priority, means that that is the router that you want to become the DR or the BDR. So after the OSPF priority comes the highest router ID, right? So we can set a router ID, and the highest router ID is going to become the DR or the BDR. The third criteria is the highest loopback address. And so if we look over here, and we'll pull that back, if we look over here, you can see that the highest loopback address is 31.33, and that has been selected as the DR. The second highest loopback becomes the BDR. And so our router would simply be a druther. And so let's take a look at, and let's see what router B's view is of the network right now and of the OSPF setup. And so you can see here we've got some OSPF messages showing us that it's the OSPF state machine has moved from full to down and then from loading to full. So we're in user exec mode. We'll go to privilege exec, and I'll type in show IP OSPF neighbors. I mistyped it again. OSPF neighbors, right? And so we're simply a druther, right? And let me get, I'm going to pull Sketchbook Express up here. Where are we at? There we go. I'm going to open up Sketchbook Express here so I can draw on the screen. Okay. Whoops, that is not what we wanted. And so let's, obviously something's in the way here, so I'm just going to drop it down here. All right, so Sketchbook Express is giving me some trouble. I'll go ahead and drop it. Whoops, get rid of it there. Pull up Desk Scribble here as well. All right, so when we're looking here, we're seeing some error messages, or I shouldn't say error messages, console logging messages. And you can see that router B, which is this router here, right? Router B sees router C as the DR, but it's not that it sees router 1 as a BDR, it sees it as a druther, right? So there's only one DR and one BDR that are elected. And then after that, everybody else on the broadcast multi-access network will become a druther. And it just stands for DR other. Now, this DR other is definitely a candidate to become a BDR and to step in if the DR were to fail. The current BDR, which is router B, the router that we're on, would become the DR, and then router A would become your BDR, your new BDR. And so we'll take a look at that here in just 1 second. So let me clear the screen here, and let's go back to the mouse. Okay, so we've been able to determine that the DR is going to be router C. Which router is our BDR? We were able to see that that's router B. So turn on IP OSPF adjacency debugging. So on router A, let's go back to router A, and we're going to type in debug IP OSPF, and let me make sure that was all I wanted, adjacencies. Right, so we're going to turn on debugging for router A. We'll go to router B and we'll do the same thing. Debug IP OSPF adjacency. And now this is going to turn debugging on, and it's going to give us a lot of valuable information about what the OSPF adjacency process does and how it establishes that adjacency. So disable the gig 00 interface on router C. So we'll pull router C up here. We'll leave the window just a little small, and we're going to disable gig 00. So we're going to go from privilege exec into global config. I'm going to go into gig 00, and I'm going to type shutdown, and we're going to shut that interface down. So after we shut it down, it says wait about 30 seconds for the dead timers to expire on router A and router B. According to the debug output, which router was elected DR and which router was elected BDR. And so we just kind of talked about this. What we should see, or what we're expecting to see, is that router A is now the new BDR, and router B, router B is going to become the new DR, since it was the BDR. So let's go to router A, and then you can see right there we've got the state machine is running, and there is a very important message, set of messages right here. So it's saying, whoops, it went by us there. So it's saying DR BDR election on gig 00, elect BDR 192.168.31.11. Now that's router A, right? That's the loopback address for router A, so it's elected as the BDR. And then elect DR as 192.168.31.22. And so then it says the DR and the BDR have been established, right, as router B, and the BDR is router A. And again, there's some additional messages. So if I do a show IP OSPF neighbors, and I'm on router B, I now see the BDR as being router A, which is at address 192.168.1.1. This is the IP address of the interface on gig 00, right? And so if I come over to router A, we see the same messages. And if I do a show IP OSPF neighbor, you can see here that now the DR is router B, right? And the address of that router is 192.168.1.2. The ID is the IP address of the loopback interface. Okay, so let's come back up here, and it says restore the link on router C. So we're going to re-enable the link, and what we're going to see here is that the election process is not preemptive. And what that means is, so we've already established that router B is going to be our DR, and router A has now taken over as the BDR. So router C, and remember we talked earlier about the criteria right over here, right? The highest loopback address, and I actually stopped short. So the fourth one is the highest physical interface. Physical interface, right? So remember we said that the criteria that we're looking at right now, so no router IDs are set, and there's no priorities that have been set. So we're dealing with the highest loopback address. And so we already talked about router C having the highest loopback address, which is at 192.168.31.33. And the reason that when we first started looking at this exercise that router C was the DR was specifically because it had the highest loopback address. So let's take a look now and let's see if this process is, whoops. We're going to go ahead and see if this process is, my pin is stuck. The pin's giving me all kinds of problems here. Let's see if we can get this. There we go. And then, all right. So we're back. So if I go ahead and type no shut, we're going to see that the interface is going to come back up. And we're going to pull up router A. And remember, we're debugging the OSPF adjacency on A and B. So that interface is going to come up on router C. And it looks like we're waiting here for spanning tree to run through its process. So this may take about 30 seconds for this to come up. And again, we should see additional output here. So the link is now up. OSPF is running on the interface, 192.168.1.3, as I believe, I'm sorry, take a look at that interface there, .1.3. And so now we're going to see some additional messages. So what's interesting is we see there's an OSPF adjacency change, that 33 went from loading to full and loading to done, or loading is all done. And then, so the state machine is making its way through the OSPF process. And now we have some messages, right? So there's link state advertisements for area 0 coming from router 1. And we see database descriptor packets, that's the DBD. Send database descriptor packets. We're on router 1 right here. Or router A, I should say. I keep saying 1, but it's A. And the database descriptor packets go out, and so then it says DR BDR election on gig 00. But you'll notice, elect BDR, it's still router A, and elect DR is still router B, even though router C has a higher loopback IP address. And so the key here is that the election it's not preemptive. So when C comes back online, just because he has a higher loopback address initially does not mean that when he comes back online after being down, that he's going to preempt router B and take over the designated router responsibilities. And you'll notice that router A continued to stay as the BDR. And so what would happen if we were to go into gig 00 on router A, and actually we want to do this, let's do this on router B. So the gig 00 interface, we'll go to global config mode and then interface subconfiguration mode for gig 00. And now we're going to shut down the DR interface, the designated router, or on router B, we're going to shut down the designated router's gig 00 interface. And so let's see what happens. And so we'll come over, we're going to have to wait, it could be about 30 seconds. We're still debugging. And so let's see what happens. And let me go ahead and roll down here. All right, so restore the gig 00 interface on router B. Which is what it has us do next. Okay, excellent. So we've disabled the interface on router B. You can see that we are seeing some debug output here. And so here comes the new debug output. And so again, And this is a key concept, right? The fact that it does not preempt. And let me bring this down. Yeah, that it does not preempt, right? So we can see what happened, right? We have here an election, and we're on router A. So here's an election for the DR BDR. So the BDR gets elected as router C, right? And the DR is router A. Because remember, router A, this was the BDR, this was the DR, and this was a DR other, or druther, right? So when this guy went away, router A promoted himself to the DR because he was the BDR. So he had a copy of all of the OSPF database and was ready to go. And other routers would be establishing, as soon as he rolls over to the DR, they're going to be establishing their communications with him on the OSPF side. And this druther, right, was still capable of becoming a BDR, right? Because there was no priority set to 0, meaning he's not going to participate. So he's just simply sitting there waiting. So now they need to have an election. So the BDR became the DR. And it was not, again, not preempted by the fact that router C has the higher loopback IP address that you can see right here. Okay, and so we end up, at the end of the day, we end up with the election where router A is the DR and router C is now the BDR. So this guy became the DR, and this is our backup designated router here. Okay. All right, let's see the next step that takes place here. Let me bring this in a little bit. All right, and so that shows us what happened. We re-enabled the link on router B. So it says turn off debugging. So on router A, we're going to say UAll, which means undebug all. So you can just put UAll, right? And we're going to bring this router, or the interface, back up on router B. We're also going to we'll do a no shut, and we'll do a UAll to stop debugging there. And we're going to pull this in just a bit. Okay, and you can see here we're going to modify the priorities here shortly. All right, so configure OSPF priorities on each router. So to change the router, or I'm sorry, to change the DR and BDR, configure the gig00 port of each router with the following interface priorities. So on router A, we're going to go ahead and say from privilege exec mode into global config mode into interface subconfiguration mode for gig00. And so if I did IP OSPF and put a question mark, you can see some of the choices we have. We could set up authentication. We could change the cost value of this interface. But we're looking at the priority. And then I'll do a question mark again. And you can see here again that the priority values that you can choose from are from 0 to 255, right? So we're going to set the priority here. And actually, before we do this, so nothing's changed. So this is still the DR. So we'll go ahead and we'll say IP OSPF priority. And if I could get the OSPF right tonight, IP OSPF priority, and we're going to say 200. So we immediately set the priority to 200. We're going to go to router B. And we're also going to set the priority for that interface. So I'm going to go ahead and say from privilege exec mode in the global config mode, interface gig00. And we're going to say IP OSPF priority. And the priority for router B is 100. And then we're going to come over to router C's gig00 interface. And I think we're already there. We'll say IP OSPF priority, and that is going to be 1. And you'll notice that it has a little note there saying 1 is in fact the default priority. If I made this a 0, again, that would mean that this router is never going to participate in the DR BDR election process. And you may be asking yourself, why? What's the use case for that? When would you do something like that? And typically with frame relay networks, there are often occasions where you will not want a router to be serving as your DR or your BDR, and so then you would set the priority to 0. But we're not going to do that here. We're going to set it to 1. All right, so now if I do a show IP OSPF, I'm sorry, yeah, show IP OSPF, OSPF neighbor, I thought I did it wrong again. Okay, you can see that the status of the routers, right, or the state of the routers in the DR, BDR election hasn't changed. The DR, and this is router C's view of OSPF right now and of the state of the different routers. Router 1 is still the DR. Router 2 simply sees it as a druther. So let's see what router B sees. So we'll type in show IP OSPF priority. And show IP, oh, I'm sorry, show IP OSPF neighbor. And you can see that router B sees router C as the BDR. And remember, router B, we had shut its interface down when it was the DR. And that's when router A became our DR, and it still sees it as the DR. And router C became the backup designated router. And so those are still the states. So even though we've changed the priority, again, it is not preemptive. And what that means is that just because we give it a lower priority or a higher priority, it's not going to override the current state of affairs within the OSPF network, right? So we're going to have to do something to get these routers to say, hey, let's have another election and let's take a look at these priorities that have now been assigned to us, and we're going to basically hold, we're going to re-elect the DR, the BDR, and then our druthers. And so again, remember, it's the higher priority that we're looking for. And remember, this is the #1 criteria that gets looked at when trying to determine who the DR and the BDR are going to be. So right out of the gate, the first thing OSPF will do is it will look at the highest OSPF priority. So router A, when we're all said and done here, router A should be your DR, router B should be our BDR, and router C, with a default priority, should just simply be a DR other, or a druther. Okay, so we need to run clear IP OSPF proc, or process, on all of the routers to reset everything. So we'll start with router A here, so I'll say clear IP OSPF proc, and I'll hit enter, and it says reset all. We'll say yes. I'm going to go to router B. We'll say clear IP OSPF proc, yes, and then router C. Clear IP OSPF proc, yes. All right. So all the adjacencies have gone down. They've been forced to reset. So we'll come back over here, and as you can see, we've got some additional messages popping up now indicating that the OSPF state machine has now gone through sort of a reconfiguration because we've cleared the OSPF process. And a quick note on that command. That is, I like to refer to that command. It's a great command to use in labs. It's a great command to speed things up in Packet Tracer when you're trying to force things to happen on your network. But that is what we like to refer to in the industry as a resume generating event. I highly recommend that you do not run this command on your production network, because it will take, as you can see here, right? It takes OSPF down and it forces it to reestablish its adjacencies. So it might not have any impact, but then again, depending on how your network is set up, this could have a severe impact, and that's why we call it a resume generating event. All right, so just a quick note on that clear IP OSPF proc command. So let's take a look now, show IP OSPF neighbors, and let's take a look at the neighbor state. And what's interesting here is you can see that router 1, I'm sorry, I keep saying router 1, router A sees router C as the BDR, and it sees router B as the druther. Now remember, the priority on router B is set to 100, and so it should have become the BDR. So let's go ahead and on router C, let's run clear IP OSPF proc again. So we'll clear everything. Went from loading to full. Show IP OSPF neighbors. And so now, after clearing the process on router C, you can see that router B is the BDR, router A is the DR, and again, let me stretch the screen here a little bit, and there are your priorities, right? So it'll actually show us what the priority of the router is. And so I believe the reason that C, because there is an order of operations here, and so I believe when I did the clear IP OSPF proc here on router B that it's possible that router C finished first and came back up and was elected as the BDR before router B had an opportunity to be elected as the BDR, even though it had a higher priority. And so the same rules are in effect. If router A goes down and I shut the interface on router A down, then the BDR, which is router B, is going to become the DR, and router C will promote itself to the BDR. And then when router A comes back up, it would simply be DR other or druther. Okay, so let's take a look here and see what we've got. Wait long enough for OSPF to converge and the DR-BDR election to occur. This should take a few minutes. You can click fast forward to speed up the process. And so let's take a look here. So there were some results. We've got 0 out of 30. So let's take a look at our assessment items. So we've got the check for the OK, and we're 3 out of 3, and we have 30 points here. So again, it looks like we may be looking at another packet tracer undocumented feature, I like to call them, instead of bugs. So it says completion is 0 out of 30, even though on the other screen it shows us as 30 out of 30. Let me check. Let's make sure it was not expecting us to save the configuration off. It didn't tell us to. I doubt that's going to get us any points. So, but we have definitely walked through all of the steps. The check results shows as much. So what I'd like to do now is take a step away from Packet Tracer and provide you with some additional resources that are highly recommended. And the first one is Cisco's website. And it was interesting, I was having a conversation with a colleague, and she was unaware that this documentation existed on the Cisco site when I had showed it to her. She had not seen these documents before. So just go to cisco.com. If you click on support, you'll come down to networking software, so iOS and NXOS, which is used, NXOS is used on the Nexus platform. And then we have different iOS releases, right? So if your lab that you're working on at your school is using 12.4, you would want to click down here. So let's take a look at 15.3 M&T. So if I click on 15.3 M&T, you can see it gives us reference guides, right? So command references, but it also gives us configuration guides. And there's 66 of them. So let's take a look under the configuration guide section. And this is actually an amazing resource for those of you out there that want to dig deeper and find out more information about the Cisco technologies that you're working with. So as you can see here, if we come under the IP routing heading, I mean, take a look at the documentation that you've got access to. So the bidirectional forwarding configuration guide, the BGP configuration guide. For those of you in 257, the third course, EIGRP configuration guide. The ISIS configuration guide, there's a Lisp configuration guide, on-demand routing, and then right here is your OSPF configuration guide. You can see there's a RIP guide, there's a PIM guide for protocol, I'm sorry, I don't believe that's PIM, protocol independent configuration guide, and then performance routing configuration guide, LAN switching configuration guide, so quality of service, security. So as you can see here, I mean, there are literally your first hop redundancy protocol. So this is going to be your HSRP or your GLBP or your VRRP. A ton of information, right? So we'll focus in on this OSPF config guide. As you can see, it's discolored. I've already clicked on it and I wanted to have this set up. So here is the config guide. You can see 448 pages of invaluable information. So if I wanted to look up something about the BDR, I could simply type in BDR and search through this document. So on non-broadcast multi-access networks, the designated router, the DR or the BDR, performs the LSA flooding. On point-to-point networks, flooding simply goes out an interface directly to a neighbor. And so that's a key thing to remember. When does this happen? Because a lot of students will become confused as to when the DR-BDR election takes place. And so, as you can see, the DR-BDR election is going to be on non-broadcast multi-access and then on broadcast multi-access, right? So we're doing broadcast multi-access over here in our example, but non-broadcast multi-access could be, I'll draw a little line up here, that could be on an ATM network. It could be on what I previously mentioned, and which is still part of the CCNA curriculum, although frame relay has been removed from the CCIE curriculum. It is still on the CCNA roadmap. Or blueprint. Sorry, blueprint was the word I was looking for. There's still the frame relay is still on the CCNA blueprint for the test, right? So this is an example of a non-broadcast multi-access network where you have DR-BDR election. And remember, I previously indicated that that was really, where you use 0 as the IP OSPF priority. These are kind of some of the cases where you would want to do that, right? And then, your legacy X25 networks, and I pray that you're not working with any X25 networks in today's day and age. All right, so again, the DR-BDR election takes place in non-broadcast multi-access networks, and it also takes place in broadcast multi-access networks. Now, where does it not take place? So you'll notice that it says on point-to-point and point-to-multipoint networks, it will not take place, right? And it also does not take place on, I think it's a point-to-multipoint non-broadcast or broadcast. I can't remember right now. So, but point-to-point and point-to-multipoint, you do not have the election of a DR and a BDR. And so I'd like to go ahead and actually demo that. And you can look here, this is just GNS3. We've got the fast Ethernet 00 interface here. So on router 1, and I think this is going to pull up, it's going to pull up, let's send this to its own window. And we're doing some pings here. And we're going to pull up router 2, which I unfortunately think is going to bring up that whole window again. So we'll send this to its own window. So we've got router 1 and router 2. Right? So we don't want to enter the initial configuration dialog for either one, and we're going to set these guys up. And now this, you'll notice on our packet tracer activity, we have a switch, and I will drop this down. We have a switch which is facilitating the broadcast multi-access nature of this activity. And let's see if we can see on the switch here. We'll go from user exec into privilege exec, and we'll do a show run, and let's see. Yeah, and it looks like show VLAN brief. Oops, show VLAN brief. I want to make sure that yeah, it doesn't look as if any new VLANs have been created. It's just VLAN 1 and then the reserve VLANs. So it's only using VLAN 1. So what's happened here is the switch is just facilitating us having a broadcast multi-access segment on switch 1 that these 3 routers are all connected into, right? They're all on the same /24 network, right? 192.168.1.2.1.3.1.1. Okay, so this is a broadcast multi-access segment here, where here you'll notice there's no switch, and we're not doing frame relay. There's no ATM switch in here, and we're certainly not doing X25. So this would be referred to as a point-to-point link. And so let's go ahead and let's configure these routers that are on either end of this point-to-point link. So we'll start with router 1. So we'll go from user exec into privilege exec and into global config. And just so we stay safe here, we'll say R1. We'll set the host name. And I'm going to go ahead and do router OSPF. We'll just do process ID 1. And I'm going to say, so there we go. So now this is interesting. I forgot this was going to happen. So when you go to start OSPF up, we have no interfaces configured here. So there's no loopback interface. There's no, none of the Ethernet interfaces are configured. And we have not established a unique router ID. And so therefore, the OSPF process cannot start. So let's go ahead and let me back out of here, and let's first do our FA00 interface. So we'll go no shut. I'm going to assign the IP address, and we'll just say 10.10.10.1. Make it a /24. All right. And so that interface is now up. So down here on router 2, let's do the same thing. We'll go from user exec to privilege exec in the global config. And the first thing I'll do is set the host name to R2. And then we're going to go into interface fast Ethernet 00. So I'm going to say no shut. And then IP address 10.10.10.2 /24, so 255.255.255.0. And so now those interfaces are both up. So if I do a do ping 10.10.10.1, the first ping fails because obviously it's going to look into its ARP cache. It does not have an entry for router 1. It does now, but it didn't prior to this. I would have run this before. It didn't occur to me to run that command prior to this. The ping does fail though while it does the ARP. So now the ARP cache is full, so subsequent pings are going to be successful right away. And so I'll come back up here and we'll say do ping 10.10.10.2. And as you can see, it's successful. And so now we have an interface, right? We have interfaces that have IP addresses on them. However, that's not going to be, it's not certainly required for the DR BDR election here because it's not, there is not going to be a DR BDR election that takes place. So let's go ahead, and I'm actually going to set the router ID, so router OSPF1, and I'm going to say router ID, and if I do a question mark, you can see, and this is what I was indicating earlier, the ID that was showing up when we did the show IP OSPF neighbors, is it was the loopback IP address. However, it's the router ID in IP address format. It's how that router is being identified within that OSPF area, and they do need to be unique. And so we'll take a look at that as well, and we'll see what happens when you get duplicate router IDs. So for router 1, we'll just say it's 1.1.1.1, right? And then I'm going to go ahead and say network 10.10.10.0, and we'll do 0.0.0.255, and then we have to say what area that interface will participate in. So we'll say area 0, and we'll do a do debug IP OSPF adjacency. And is it, oh, I think it's whoops, debug IP OSPF adjacency. There we go. I left out the IP. All right, so router 1 is all set up. He's got debugging on. We've got OSPF running on the interface that's directly connected to router 2. And we've set the router ID as 1.1.1.1. And remember, that is, it's an IP address format, but this is not being used as an IP address. So I'm not going to be able to ping 1.1.1.1. And so here's what's interesting. And again, it's GNS, right? This is GNS 3. However, you actually have to have for what I'm doing with the Cisco 3745s that I have on the screen here, you have to have the actual Cisco iOS software. So this is, when I do things like this with my lab rack, this is the real deal Cisco iOS. And so this is, in real life, this is what you'll see. And we're running 12.4.25D is the software version that I'm running here, Advanced Enterprise Services, right? And so take a look at what happened. So we started OSPF up on that interface. The state machine then says it's going to do a DR BDR election on fast Ethernet 00. So, and this is interesting, that the BDR is elected first. The BDR is elected before the DR is elected. So it looks around and says, yep, I'm good for the BDR, but then it says, you know what? I'm actually good enough to be the DR. And again, we're on a point-to-point link, right? So it doesn't realize right now that we're on a point-to-point link. And so here's where you've got the elect BDR 000, elect DR 1111. So it has elected itself, and you'll notice it's using the router ID, which is the second criteria. We come back over here, the router ID, if there's no priority, it's the router ID that it's going to use. So now this is interesting. OSPF says no full neighbors to build network LSA for interface fast Ethernet 00. So let's go ahead and do some work on router 2 to make that happen, and let's see what happens. So right now, if I do a show IP OSPF neighbors, we get nothing because there are no neighbors. If I do a show IP OSPF database, you can see, and this is your link state, your LSA type 1, right? This is the router LSA, okay? And you can see that he only sees one link, which is the link that's up right now. The advertising router is itself, right? And you'll see it's using that router ID, right? And here's the link ID, okay? And the router and the advertising router. And it's using the router ID that we established as the link ID and the advertising router ID. So back onto router 2, and let me do a debug IP OSPF adjacency, right? So we can see what's going to happen here. So I'm in the interface. So let's say router OSPF 1, process ID of 1, and a key thing to remember here is that unlike EIGRP, and you may remember this is from the, I believe, the second course. Yeah, I think it's the 158 course, the second of the two courses, the routing and trying to remember here. Routing and Switching Essentials. I had to turn and look at the book. Routing and Switching Essentials, where the OSPF process ID, this is locally significant. It does not have a meaning outside of this router's knowledge, right? So I could have said router OSPF. In fact, here let's do that, right? So if I do no router OSPF 1, I could say router OSPF, and what is the limit here? 65. So I could, whoops. So we'll say router OSPF 732, right? Just to prove the point that the OSPF process IDs between two routers establishing an adjacency does not have to match. Okay, so we've got router process ID 732 for OSPF. So now let's go ahead and set the router ID on this guy, and we're going to set it, and we'll set it intentionally to 1.1.1.1. So we know this is going to be a problem because the other router already has that router ID set up. Router 1 has router ID 1111. All right, so now let's start up on 10.10.10.0 and 0.0.0.255 area 0. We're going to go ahead and start that interface up, and boy, right away router 1 does not like what it sees. But it's nice because it tells you the very descriptive message here immediately. Duplicate router ID from 10.10.10.2 on interface fast Ethernet 0. And so you'll look down here, duplicate router ID on 111. Now, is that enough to prevent the adjacency from forming. So let's do a show IP OSPF neighbor, and sure enough it is. You'll notice that neither router is establishing an adjacency, and so we'll see what happens here. And now what's happened is you've got the BDR as 1111, you've got the DR as 1111, but there's no full neighbors because the adjacency has not been established. So do show IP OSPF neighbors, and we've got nothing. So let's go ahead and let's fix that router ID. I just wanted you to see that real quickly so that you can recognize this is how that happens, and that's what it means. So I'm going to say no router ID 1.1.1.1. All right, and there it goes. So as soon as I remove that bogus router ID, it's doing the link state update, so I'll give it a good router ID. So we'll say router ID 2.2.2.2, right? And so on this point-to-point link, if I do a show IP OSPF neighbor at this point, you can see that the election has taken place. So router 1 sees itself as the DR, and let's take a look at router 2's view, show IP OSPF neighbor, and router 1 is now seen as the DR. So the election took place, but we're going to change things. We're going to change this, and we're going to go ahead and say on interface fast Ethernet 0.0.0, we're going to say IP OSPF network, and I'm going to change this to point-to-point, right? So as soon as I change it to point-to-point, let's take a look at what happens here. And we're actually going to scroll back. First, we're going to set this guy as well, conf t, and we're simply changing the OSPF network type to force this to point-to-point so that you can see how this is going to behave. So I'm going to go ahead and say interface fast Ethernet 0.0, IP OSPF network, and it's going to be point-to-point, right? And this is exactly what we were hoping to see. So again, we've got this point-to-point link, right, that we've now told OSPF, you are to treat this communication between these two routers as a point-to-point link. And look what happened. So the DR BDR election comes up because it's a point-to-point link, and now neither router is selected. Another key thing to note here is that you can see that the routers are remembering who the old DR was. Okay, so now when we come back and we do a show IP OSPF neighbor, you can see it shows the state as full. However, this is where it would say DR or BDR or druther. But we've configured OSPF to function as a point-to-point network here. And so by changing the network type to point-to-point, there is no DR-BDR election, because what we're saying is these are the only two routers that are on this segment, and they're communicating with each other, right? Okay, so that proves that not only can you not have the same router ID on two routers that are trying to form an adjacency, you're going to see error messages, and when you change the network type to point-to-point, that it is, even if you had previously elected DRs and BDRs, that they're going to go away. And now, now it's simply full, right? And there is no DR, BDR, druther, because this is a point-to-point network. All right, so let me go ahead and drop these guys down here. And the Marriott, I'm not sure what the Marriott window is doing up. I want to leave this guy up here. So a few other resources that a lot of students are not aware of. So if you go to Cisco Live 365.com, so if I were to go, it's going to redirect, but Cisco Live 365.com, and I'll type in my user ID and then my password forms, and I'm going to log in here. So this is another incredible resource. So every year, Cisco runs an event called Cisco Live. As you can see, they've already set it up for Milan, Italy from the 26th to the 30th of January of 2015. You can register now. In the United States, it's taking place in San Diego for 2015 in June. And every single year the conference runs, the sessions are recorded, and the PowerPoints are made available. So if you wanted to know about OSPF, you could search for OSPF, and you can see here, you can go back 2 years and say, I want to see any session that dealt with OSPF that was in San Francisco. And take a look at this. I mean, these are some amazing sessions. OSPF deployment in modern networks, troubleshooting OSPF, routed fast convergence, hardcore IPv6 routing. You've got DMVPN. So we're interested in OSPF right now. So if you wanted to see troubleshooting OSPF, you simply click on it. You've got full access, and this is free. All you have to do is register for the account, and you can get in here for free. Troubleshooting EIGRP, so it recommends additional sessions that are similar to the session that you're looking at. Troubleshooting BGP, and these sessions are packed, 1.5 to 2 hours long. If you only want to get the PDF and take a look at the PDF, you can certainly do that. And we'll let this fill in here. And so take a look at this, 107 slides. And it's all about troubleshooting OSPF. And I've watched this session multiple times. It's a fantastic session. Talks about the LSA types. They go into a description of basically which commands to run. And you can redraw your network out. If you had no network diagram at all and you were running OSPF, they teach you how to walk through and be able to recreate that network. Here's your router link summary types, right? And this is an amazing session. So let me iconify that. And again, the session video, if you click on the session video, it will actually pull up the full recorded version or the full recorded session that took place. And this typically takes a couple seconds to load because, again, these are, in some cases, 2 hours long. And so if you're not able to make it to Cisco Live, these typically become available a couple weeks after the event runs. And I'm going to drop the volume here. And so you can see here's the individual providing, who's talking about the session, Faraj Shazim, and his slides will rotate through here. And so he'll talk about all of the different aspects of troubleshooting OSPF. And so again, this is a completely free resource. And then finally, never underestimate the power of the RFC, or the request for comments. And so the OSPF v2 RFC is 2328, and you can also pull that down in PDF format. And so if you want to take a look at it in PDF, if that maybe you want to put it onto your mobile device or in your Google Drive or your Dropbox, I'll go ahead and open it here with Acrobat. And so here is the OSPF version 2 RFC. So in here, if I wanted to see what the RFC says about BDRs, and it actually didn't find it, let me type in designated. And so here you go right here, the designated router, the backup designated router. So let's go to page 54. And it says every broadcast and non-broadcast multi-access network has a designated router. And so really what was happening is, you know, different vendors, Cisco and Juniper and HP, they're following the RFCs in a lot of cases and implementing things in a standardized fashion so that the same behavior can be witnessed across their platforms and their software. So the designated router performs two main functions for the routing protocol. So it originates the network LSA on behalf of the whole network, and the LSA lists the set of routers, including the designated router itself currently attached to the network. And then if we scroll down, the DR becomes adjacent to all other routers on the network. And that, when we looked at that show IP OSPF neighbor, that shows you who's becoming adjacent to whom, right? And so again, a lot of people feel that maybe the reading here is dry, but I can definitely tell you that this is an amazing, the RFCs are an amazing source of information that talk about the standards and what the standards are supposed to look like when implemented. And so the RFCs 2328 is your OSPF RFC. Okay, so back to the packet tracer activity. We've wrapped this packet tracer activity up. I know we kind of went off on a few tangents there, but I wanted to make sure that I gave you that information because a lot of students are not aware of some of the just amazing resources that are out there with respect to Cisco and Cisco's technologies. I'm actually going to be doing some Juniper videos here shortly, probably starting this weekend, working with JunoS, and I've got a couple of EX3200s that I'm going to be using to do those demonstrations on. So you'll be looking to see some, how JunoS, if you're interested in that, how they do their configuration and how they start up OSPF and how they configure OSPF. All right, so again, quick points, right? The DR and the BDR election process. The first is the highest OSPF priority. 1 is your default. 0 means it's never going to participate in the OSPF BDR and BDR DR election process. 255 means, hey, I want this guy to become the DR. The second criteria will be the router ID. So if OSPF priority is not set, it's going to look to see, is the router ID set? The highest router ID is going to become your DR and your BDR. And then you've got the highest loopback address. So if the first two aren't configured, it looks for a loopback address, which could be any loopback address. And as a best practice, I highly recommend that you set your priorities and that you also set your router IDs as a best practice, because you don't want it grabbing a random loopback address that may have nothing to do with the OSPF segment, right? So, and then finally, and this is kind of worst case scenario, is it's simply going to grab the highest numbered highest numbered IP physical interface. And again, you don't want to get there. So as a best practice, always set the router ID, always set your priorities. It also makes things deterministic, which means you're going to know if my router with the OSPF priority of 255 goes down, that the router that I set the priority to be 254 on should become my BDR, right? And that the router that you set the priority to 0 on is never going to participate, okay? Same thing with the router IDs, makes it much easier to identify. Okay, so this has been a extended tutorial on packet tracer activity 5.1.2.12. Hopefully you found the information, the additional information useful. Again, some great resources that are out there for those of you really looking to take your game to the next level with respect to Cisco technologies. All right, thank you very much for watching the video. I hope you found this useful, and best of luck to you in your studies.